I see we have two separate schools on. We've got a couple community members around. Who has actually, seen a volcano erupt within Alaska? I feel like everyone's always got one or two stories of being around for either Redoubt or Spur. Shishaldin is relatively nearby. Nothing. Even easier. Well, so I am, again, mostly here just to talk about volcanoes in Alaska. What are they doing right now? How we actually, look at them, how we monitor volcanoes and start to develop frameworks around things. So Alaska is a very interesting place from a standpoint of volcanology, the study of volcanoes. We have 53 active volcanoes in the state, with several major eruptions every year. There's more than anywhere else in the US. It's a quite an active area. And generally, volcanologists in the state, people who are worried about fallout, are mostly concerned about ash. That is the largest kind of relative concern here. Has anyone had a flight that has been disrupted from a volcanic eruption? I imagine most people have. So in Alaska, not only are we contending with all of those volcanoes that we have out in the Aleutian Peninsula, but we're also contending with a lot of volcanoes off in Kamchatka, which also very frequently produces pretty heavy ash clouds. I just had a flight delayed a couple of weeks ago due to a Kamchatkan volcano. But overall, there are, teams of volcanologists, mostly affiliated with the Alaska Volcano Observatory, who are consistently in charge of monitoring the volcanoes in this state. And it's kind of a unique charge for most of them. A lot of volcanoes, once you start to get into slightly more populated areas, once you're, looking at Mount St. Helens, when you're looking at Rainier, these are all places that are, relatively accessible. It's very hard to hike up to the top of Mount St. Helens, but you can definitely get onto a helicopter and go up there. It's a whole other ball game once you're dealing with a huge quantity of volcanoes and the sheer enormity and isolation of the Aleutian Islands. The actual process of figuring out, how do we monitor these things? How do we look at volcanoes throughout the Aleutians is complex in and of itself. So because of that, a lot of, what we are interested in within this state is just getting as much information as we can and as reliably as we can. So what type of information are we getting? What are people usually interested in with volcanoes? Well, in general, when we monitor volcanoes, when we look at them, a lot of the charge of government institutions, we're interested in forecasting. It's kind of like reverse weather forecasting, right? If you look at, the weather forecast for tomorrow or for, a couple of days from now, it's usually pretty accurate. But once you start to look at weather forecasts a week, 2 weeks out into the future, they start get pretty, spotty, right? It's hard to tell reliably if it's going to rain 2 weeks from now, unless you're, living off in Sitka or Juneau or somewhere else, in which case, statistically, probably it will rain. Uh, but, other than that, a lot of volcanology is kind of, yeah, reverse that. It's very easy to kind of understand that there tend to be patterns or cyclicity to eruptive sequences. Mount St. Helens can sometimes erupt once every couple hundred years. Rainier can erupt once every couple hundred years. But the actual useful part of forecasting eruptions, the useful part of being able to, be like, is the volcano going to erupt tomorrow or 12 hours from now or 2 weeks from now? That's where things get really difficult and where a lot of the, intricacies come in to this process. So in general, what we're interested in when we look at volcanoes is kind of, is there any change with what it's normally doing? If you go to your annual checkup at the doctor's office, they take your pulse, they take your blood pressure, they look for your cholesterol, they examine a suite of things and kind of it's potentially difficult or problematic if there's a change in any of those things. In the same way, out in the Aleutians, often we have teams of scientists who go out once a year, once every 2 years, and start to kind of do this larger volcano checkup. Often, what we look at are a combination of a series of things. I myself look at the emission of volcanic gases. So I essentially try to quantify how much and what is coming out of a lot of different volcanoes. This turns out, to be a fairly good tool, is in the same way that, it's hard to directly look inside of you when you're going for an annual checkup or when you're visiting a doctor. It's really hard to look inside of a volcano, right? It's difficult to drill down several kilometers and just put a camera in to see what's going on. It's very hot. There's a large amount of pressure, too much work. As it turns out, looking at gases that comes out of volcanoes is a pretty good indication, or can be used as a pretty good indication for what's going on underneath. In the same way, a lot of other people look at inflation of volcanoes using GPS measurements, really, really hyperactive ones or really hyper accurate ones. So whether or not the volcano itself is blowing up, essentially, if there's been more magma coming in underneath, rocks over large areas can bend a little. So people look at inflation, people look at, whether or not there's seismicity around volcanoes, and then a couple of other things. Infrasound often gets used a lot, especially, around Alaska, where sometimes if we can actually detect an eruption, that's kind of a success in and of itself. Sometimes these things just happen in the background and we don't even know about it, which is kind of a fun thing to think about. Otherwise, people look at, changes in morphology, other stuff, whether or not there's a change in, a lake going on at the surface of it, whether or not there's new discolorations or fun things happening. So all these things together kind of helps us to define a framework. And when we look at volcanoes holistically in the state, we kind of establish or attempt to establish a baseline in activity. So earthquakes, seismic activity that occurs at volcanoes is pretty common and it happens all of the time, very frequently. Very, very low magnitude earthquakes just in the background. But suddenly, if there's been, say, a spike in earthquakes, large deviations in, the rough quantity of earthquakes that are happening every week, that's potentially worrying. Uh, if the volcano seems to be puffing up, if it's expanding, that's kind of worrying. Uh, if gas emissions are suddenly changing a lot, those are all things that people start to look at when we're, figuring out, is the volcano doing something new? Uh, in the case of Spur, which was, much more, recent example of a volcano, which has kind of changed in color code over the last, year and a bit. Spur is near Anchorage, about 80 or so miles away. It's a pretty high threat volcano in that it's just directly close to a major population center. And, you know, Spur has kind of been chugging away since the last eruption in 92, 93. It hasn't really been doing that much. Suddenly, over the last year and a bit, people started to notice on seismometers large upticks in the frequency and like amount and magnitude of earthquakes occurring around Spur. The same way, people also started to notice inflation or the volcano was puffing up. People started to measure gas coming out, became a challenge in and of itself. Uh, and that kind of prompted people to start to, ask, has there been a change? Is there, a shift in what is kind of happening as far as background activity with this volcano? Uh, as a function of that, color code raised. So in the state of Alaska, we have kind of decided to classify volcanoes by color code. It is consistent with the rest of America as well. So whether or not a volcano is in a state of activity or erupting, it's kind of this spectrum between green and red. There's green, yellow, orange, red. And these are all terms that are formally kind of identified on the Alaska Volcano Observatory website. So pretty much the volcano is kind of chugging along in the background, then it usually stays at green. Sometimes volcanoes shift off to unmonitored. And this is mostly because we have decided that in this state, we will consider a volcano to be monitored if it has three seismic stations that are operating within 20 kilometers of the volcano. It's kind of just an arbitrary distinction that we have drawn, but it's a distinction. It's a way to kind of decide, are we looking at this enough or not? Uh, if volcanoes start to, move from a green state, just this normal background chugging along, not really doing much, then they get upgraded to yellow. Often, volcanoes can kind of stick around yellow for a little bit, just in raised activity without erupting. This doesn't happen everywhere, but in some places it does. For Spur recently, bunch of earthquakes consistently, bunch of seismic activity, a lot of gas emissions. That kind of seems to have dropped down again. This kind of gets referred to as a failed eruption. So if activity just kind of peters off, we kind of move volcanoes back to green once everything is kind of gone back near background levels of activity. So overall, this concept of a failed eruption is just fundamentally a pretty complex thing because what's happening underneath the volcano is a very complex series of processes, right? You have magma that's moving up and it's trying to get up to the surface, but rock, all the stuff between the magma and the surface, doesn't really want to let it move anywhere, right? So often, sometimes you have magma coming up and there's just too much rock, or circumstances aren't necessarily conducive to it actually being able to get to the surface. In fact, we produce a lot of magma as a planet, huge amount of magma, and most of the magma that we produce doesn't actually make it to surface. If you've ever gone out hiking and you've seen a granite anywhere, that just fundamentally represents a bunch of magma that has not actually made it to the surface of the Earth. Ah, if in some cases of our volcanoes, we get, increased activity that leads to an eruption, then things either get bumped up to orange or red, mostly depending on the severity of the eruption. So in the state of Alaska, we have all different flavors of volcanoes. We have all different flavors and types of eruptions that are happening right now. Large, very, proximal or threatening eruptions tend to stick at red. More low-level eruptive activity tends to stick at orange. One example of that right now, we have one volcano that is sitting around at orange right now, Great Sitkin. It's been erupting for about the past 2 years as a very, very slow lava flow. There's not like a huge ash cloud coming out of it or anything, but it's still emitting lava consistently every day, about an Olympic pool's size worth of lava. I think a Paris Olympic pool worth of lava, which is kind of great. It's one of the few lava flows that we have on this planet. Consistently, we, will have low levels of eruptions that are putting things or ejecting material into, a couple miles of the atmosphere. Uh, we will, put ash out and then deposit a lot of stuff near volcanoes. rather than like, around population centers. But this kind of leads to some really fun features that are only really up here. Shishaldin, which you guys are not super, super far from, is a volcano that was recently erupting in the state. Uh, Again, about 2 years ago. For a little bit, that volcano had a lava lake in it. People flew over and took video of this. And, at any given time on Earth, there's maybe, 7, 8 volcanoes that really have lava lakes, which is kind of fun. So all of these things just kind of exist in the state, out in the Aleutians, out in the peninsula, across the Alaska Range. And the actual job of, looking at these things is difficult. It's challenging. Uh, that's kind of a rough spiel about, volcanoes, volcano monitoring in the state. What I thought might be more productive is just, asking questions about volcanoes. What are you people interested? What can I help to answer related to volcanoes? There are no bad questions around them.
Hi, my name's Tim. I've been over to Togiak a bunch of times,
Yeah,
and
yeah.
when we fly over there, there's a Tuya, the Togiak Tuya. Are you familiar
Yes.
with this? And what's the history of that?
Oh gosh. I am not super familiar with the specific history of that. Uh so this does actually bring up like another really like interesting discussion point though, because like, Alaska, the geologic history, how rocks have developed and moved around the state over the last, billion years is really quite complex. Uh so while we do have like 53 historically active volcanoes, we have over 100, Holocene volcanoes. Uh, so a lot of the times when we talk about historical or activity, we as scientists, as people, we want to be able to establish kind of helpful baseline definitions for things, right? Uh, if you're off in like Japan or Italy, there are often like fairly extensive records written with like exact dates on, when Mount Fuji last erupted. Was it 2,000 years ago? Was it, well, not that far back, but, they're like kind of written records to put dates on things. We do have like traditional knowledge for establishing whether or not things have been seen to have erupting around certain time periods that have been incredibly useful. But generally, anything that is defined in the state as a historically active volcano is anything that's kind of erupted since like about 1700 to present. So the last couple hundred years. Beyond that, though, there are a lot of volcanoes in this state that have erupted within the last, 10,000 years, give or take, within the Holocene period that we're sitting in now. Uh, these things might erupt again, they might not. Most of them won't. And that's kind of one of the other very cool things about volcanoes. They're, these transient features geologically. Just because something has erupted in the past doesn't necessarily mean it's going to erupt again. Eventually, all volcanoes stop erupting. In terms of Kodiak, I believe there are no historically active volcanoes on it. However, I believe there may be one or two Holocene volcanoes.
Not Kodiak, just for the record.
Ah, sorry, not Kodiak.
Not Kodiak, Togiak.
Oh, Togiak. Ah, so sorry.
That's okay.
Yes. So not too sure about like the specific volcanic history of that area.
Thank you.
No worries.
Go for it, Sue.
Was somebody else trying to,
Yes.
or is that an echo?
No, they're trying to.
Oh, let's let that. Record
Can you
new
hear?
hair.
I can hear you. Yeah, yeah.
Can you
Oop. There's some reverb.
history of Iliamna volcano? Because we are located in near Iliamna. New Haven is
Yes.
right neighboring Iliamna.
You're very close to Iliamna. I did not catch the first part of that.
We were just wondering the history of the volcano, if you know if it's ever erupted or any other
Uh,
information.
Indeed. Iliamna has indeed erupted. Very recently, in fact. I am going to direct you, and really a very helpful resource for understanding a lot of volcanoes in this state. Ha! Are you seeing my screen?
Yes, we're seeing it.
Amazing. Uh, a lot of like very specific questions. If you're looking for exact numbers on things, anything else, other useful bits and pieces of information, the Alaska Volcano Observatory, uh, run through joint partnership with the USGS, DGGS, the State Geological Service, UAF. What they do is functionally monitor all these volcanoes. So one part of monitoring is, in fact, kind of understanding when the last time it's erupted, the cyclicity of it. So Iliamna, right here, very conveniently, there are a bunch of available areas which you can go at to start poking around different volcanoes in the state, not only to see where they're at. In this case, Iliamna, which is right here, is sitting around at green. You can kind of use this to also inform yourself. But there are a bunch of new kind of interactive features that AVO has slowly started to roll out. So if you're very interested in the eruptive history of Iliamna, there's a very helpful slidey bar over here that you can go back and start to look at very specific either pieces of local knowledge or stories, if you've, you know, got or incorporated that, or other little bits and pieces of activity that people all try to chronicle towards when the volcano is specifically doing what. Ah, other things that you can use or do via the AVO website, all of which are very helpful. You can kind of see where individual monitoring stations are near the volcano, these kind of instrument subpanels. Some volcanoes do have webcams. This is Iliamna right now, not great. Uh, but every once in a while, whoop, yep, no, it's just cloudy. Uh, Occasionally, it's less cloudy and you can actually get a pretty good view of things. Everything else around it, all these small circles here, these are all earthquakes that have been picked up and registered by all these stations. Beyond that, whoop, ash forecasting is available right now for Iliamna. Might be down for now. Which is fine. Yes. If there are like specific things you're interested in looking at via Iliamna, you can find them all on the AVO website. There's a full comprehensive list of about everything that people have realized or registered. We have some record of eruptions going back about 7,000 years, another eruption about 4,000 years ago. But all of these volcanoes are still, not fully studied. There's a lot of ongoing mysteries that we have about these places because it's so difficult to get there. We have students that are continuously working on different bits and pieces of research projects associated with finding new historical eruptions, anything else. It's also difficult. A lot of these volcanoes are covered by ice. Makes it hard to look at the rock.
So I'm gonna add a comment to that. And
Absolutely.
I'm over in the corner, but just for communities, villages, just know that a lot of tribes that are funded by EPA, Environmental Protection Agency, for IGAP, Indian General Assistance Program, a lot of them are doing emergency response plans, SCRP, Small Community Emergency Response Plans, and keeping those active. I'm sure that those plans also, as they get updated, also include the links to AVO and what you were just showing us. So that's just one comment, and keep in the back of your mind too, whether it's New Helen or any other villages, Bristol Bay Native Association is very active in terms of helping communities with that, in addition to EPA. So my question though, was, I've been to Chignik Bay a lot, and I assume you have been also, right?
I have not.
Oh, so anyways, so I do work with Chignik Bay Tribe and some of the communities around there.
Amazing.
Yeah, and so anyways, and AVO and the other folks have been based out of there quite a bit.
Yes.
With the
Yes.
helicopters and gathering data, and it's just always fascinating to listen to them. But leading up to my question, you guys rely to a large extent on federal funding, and so AVO is a really important entity. And can you kind of give us a sense of to what extent that's going to be scaled back? In terms of the outreach they do and the data they collect?
Yeah. So, I can definitely say that I'm not a representative of the Alaska Volcano Observatory right now. I was affiliated with them as a graduate student, but I am down the street and still have many friends over there and talk with them regularly. Yeah, I mean, the Luckily, there have been a lot of very frustrating federal cuts to a lot of agencies limiting their capacity recently. I do think one of the things that's been helpful for AVO was the uptick of activity at Spur recently. I think that definitely made like their use and purpose very clear. Uh, Other than that, I think that like a lot of volcano funding has, at the very least, historically been a pretty bipartisan issue. Uh, like certainly state senators for Alaska have historically supported the mandate of the observatory. It's kind of like an easy thing to understand just by like looking at it and understanding volcano threat, please fund this. Uh, So, yes, there's no like, I mean, I don't anticipate any very large depreciation in either services or community outreach. The people that are at AVO are still very committed to trying to do as much outreach as possible. I think they've really upped their mandate of doing that recently. And like most of the work that has been done thus far over the last give or take 5 or 6 years, the state has largely been shoring up all of these networks, all of these, you know, systems of seismometers and monitoring stations that are already out and deployed. So once those things are out, the actual process of doing annual maintenance, upkeep, everything else on them, that kind of becomes a little bit cheaper, a little bit more affordable. Uh, again, it's kind of like,
Leads up to my follow-up question.
yeah,
Okay, so again, going back to Chignik, because these guys were it was AVO, a bunch of other folks stationed there
oh
for,
yeah,
probably a month with a helicopter maintenance going and so forth.
oh
But
yeah.
my follow-up question is, can you explain the connection between volcanic eruptions, tsunamis, and if my understanding is Chignik Bay is the only community within the entire Biscay Bay region that has a tsunami warning system.
Yeah, I mean, so there's a full tsunami center. I do not work with them. But there is it is an interesting question in the sciences in general, whether or not, earthquakes and other things that lead to large tsunami actually, result in volcanic eruptions. There's kind of an unclear connection there overall. Uh, in general, though, like, we do have earthquakes that happen, right, in the state, quite large ones, mostly just as a function of the fact that we have one very large plate that is hitting in to Alaska and subducting down. It's building up, it's moving every year and just building up force, more and more force. And eventually it kind of fails and slips. And then you get this huge release of energy, earthquakes. Whenever you get like big momentum of things, if you get in and out of the bathtub, that makes a wave. Earthquakes work in the same way. For Chignik Bay, I mean, one of the issues then becomes it's, this bay. So if you're pushing this huge amount of water into a bay type area, often this can amplify things. In the case of the link between volcanoes and tsunami, there are historically tsunami that are associated with volcanic eruptions, but the caveat to that is these are usually volcanic eruptions that happen in the ocean. So for Chignik Bay, nearest volcano is Veniaminoff. Again, big volcano, really cool. But like Veniaminoff is inland for the most part. It's like in the middle of the peninsula. So what you need to do in order to get a tsunami is you have to move a large amount of material and you have to just dump it into a body of water such that it makes a big wave or displaces water. And that process is what leads or creates a tsunami. So for Chignik, I think the general tsunami risk is likely more a function of like earthquakes than potential volcanic eruption. Uh, yeah, beyond that, I mean, other communities that are located around bays on the backside of the Alaska Peninsula, so outside of, communities at risk down here, anything on the back end, Port Heiden, anything in that area, you know, we don't really get earthquakes back there that are, very large or potentially destructive. So the interest in tsunami monitoring within this state is mostly just on the front end of the peninsula moving down to the Aleutians, if that
Gotcha.
makes sense.
No, it does. And then a good friend of mine who's the environmental director for Chignik Bay Tribe, she grew up in the Chigniks, and after, and I never pronounce it correctly, Kamchatka. How do you say that? Kamchatka. But it was interesting because, she said the only effect that she noticed when she was walking along the beach was that, and their tides are not as big as they are here, like in the Nushagak and the Kvichak. But she said it was interesting because the tide would come in and go out a lot more frequently over a period of, I don't know, a day or two. And
That's cool.
yeah, anyways, it didn't affect them obviously, but that's what she noticed when she was, walking the beach with grandkids, that kind of thing.
Skye, you have another question in the chat from
Oh,
Newbie.
yes,
If you could, I know you talked
absolutely.
about.
I can see it now. Sorry. Yes. How can you tell it erupted 7,000 years ago? Which I assume is in relation to Iliamna. So there are actually a couple of different really cool techniques that different geologists can use to date rocks. Uh, in the case of a lot of, these types of volcanic eruptions, often what we're looking at is whether or not material has built up radiation since being exposed to the sun. So if we have an eruption, often, we will bury a bunch of material and suddenly, it's underneath more stuff. Once you have something that's kind of blocked off from the sun, these materials tend to accumulate specific types of radiation or specific types of particles that would normally kind of be emitted as a result of interaction with sunlight. The more time you spend out of the sun, the more time you kind of build these things up. Uh, and like that's generally how, anthropologists, geologists, other people can date individual layers of material. Beyond people can look at individual minerals sitting around inside of rocks and be like, okay, this mineral has been formed, a certain amount of thousands of years ago, mostly as a function of just the decay of unstable isotopes, which is probably not a helpful system of words. There are elements in rocks, and some of those elements over time turn into other elements. We can tell by how much of like the elements that turn into other elements and the things they've turned into, we can look at that and we can be like, okay, this material is like many thousands of years old. And one of the cool things about geology is we can do that for things that are like pretty young geologically, like 8,000 years old, 2,000 years old, or we can do it for things that are like 4 billion years old. There's a whole gambit of things that we can actually look at and try to put age dates on, even though we weren't necessarily around to see it. For some things like, eruptions that happened 8,000 years ago, we're usually pretty accurate with that. This thing might have happened 8,000 years ago, give or take, 100, 200 years. There's always some uncertainty built into it. For like very, very old material, it's hard to get that type of accuracy. For like, things that are 2 billion years old, we can often tell that it's like 2 billion years old plus or minus, a couple 100 million years, give or take.
Yeah, in the back. You're gonna have to shout.
Hi, I'm Margaret. From what I understand, there's been an uptick of seismic activity around Sandpoint, and I was wondering if that's playing into the way that you're monitoring those volcanoes in that area, or if it's high enough levels to increase risk of eruption around the Chignik and Sandpoint area.
Could you hear
Ah,
that?
I think I caught that. Uptick in seismic activity around Sandpoint.
Yes.
Yeah, cool. Yeah. So, I do much less seismic monitoring now, as a whole. But so I'm not sure whether or not there's been an uptick, but very helpfully, again, like I really like the interface for the tool that the Volcano Observatory is putting out. Uh, like if you want to go to it yourself, like seismic activity just kind of happens, right? It's normal. It happens everywhere pretty constantly throughout the earth at like very low magnitudes, right? When people talk about earthquakes that are like magnitude 1 or 2 earthquakes, these aren't things that you would typically be able to feel. Uh, so you can have, an increase in seismic activity around a volcano, and there might not necessarily be any associated, eruption or anything happening with it. Generally, when people are looking at, seismic activity, they're looking for a couple of different things. They're looking for whether or not there's like a pattern to it as opposed to a bunch of random dots. So, just base numbers, is there more? Potentially there is, but maybe there also isn't. It's very hard sometimes to look at seismic activity. Also, we've been putting out a bunch of new instruments at different volcanoes over the last couple of years. So we've really been we've been establishing a new baseline. Uh, Essentially. If we're suddenly able to detect more earthquakes, then like has the baseline changed or has our detection capacity gotten better? Other important things, are earthquakes moving? Are they clustering into an area? If there's like a small area in a map at a certain depth that has a lot of earthquakes happening in it, then like that's of interest to people. That allows us to tell like, okay, maybe something is happening there to produce like a lot of very small earthquakes. That's actually moving material in a large amount. And people are just interested in like, magnitudes. Are there larger earthquakes happening? Do things appear to be getting more shallow? Are they moving closer to surface? Uh, Overall, like, it's kind of a conversation, right? So like if there are more earthquakes, but people feel it's kind of like about the same or not like an established pattern, then usually people don't move volcanoes up to like a yellow. Generally speaking, eruptions don't happen like all of a sudden without very few warning signs. There are some volcanoes that do kind of do this, but usually, especially on the peninsula within like actual Alaska, within Alaska and not out in the Aleutians, we usually have an uptick in seismic activity before eruptions that lasts for several weeks. So, like, there's always a chance to kind of understand this. It's not like necessarily a matter of there's 15 more earthquakes next week, and then suddenly the volcano erupts, which is helpful.
You saw the question in the chat?
I did. Yeah, volcanic activity in like some of these areas are weird, and I think like there are a bunch of weird fallouts of volcanoes. Chemically diverse areas, which is helpful. There are some volcanoes that do appear to lead to some amount of high environmental productivity, but there's others that don't necessarily. If you have like gas coming out of volcanoes, that gas often really acidic, right? Uh, there are some volcanoes where you actually have decreased productivity around a volcano. Uh, as it turns out, coming out of the top of a lot of volcanoes pretty persistently, uh, there will be like, you know, about a couple hundred tons a day of like different gaseous species. Usually sulfur dioxide is like a very big thing that comes out of volcanoes. Sulfur dioxide, if you're around water, that turns into sulfuric acid. It's like usually immediate areas around a volcano can actually be quite unproductive. I think a lot of the, location and external environmental areas in Alaska kind of make things much more interesting for like productive for salmon runs. And then, the volcanoes often work against this process. Uh, yes, Mount Edgecumbe. Edgecumbe is a weird thing. The question of whether or not a volcano will like ever erupt again is like pretty hard to answer in the same way that, it's hard to really say definitively. In sciences, we usually don't like to make definitive statements like this will happen. I am 100% sure. But like most likely, Edgecumbe might erupt again. There are a couple of volcanoes in the state where we think that's going to happen. Edgecumbe has been like a kind of a weird case. Uh, I was around the observatory when it got kind of bumped up, but It was a like a really fun example of how we sometimes make accidental discoveries and how like it's just functionally difficult to look at the amount of area that we have in Alaska by a small group of people looking at volcanoes. For Edgecumbe, it's this nice little volcano outside of Sitka, fun volcanic area, famous tire fire in the 70s or 80s, where somebody April Fools uh, everyone by starting a tire fire in the caldera. Uh, but yeah, one of the geodesists, one of the people who looks at how ground is moving around different areas, started to look at Edgecumbe and found out it was actually the second fastest inflating site within the United States. This is like mid 2021, 2022. I can't remember the exact year, but this prompted a bunch of people to become very interested in Edgecombe very fast. So when, again, magma, there's like a bunch of molten rock, other stuff, is coming up beneath the surface. It's very light. It's very buoyant relative to rock. So it wants to go up. It wants to get to the surface. As it's pushing up, as magma pushes up, again, rock can flex. Rocks can move a little bit, a couple of centimeters over a fairly large area. And as it turns out, Edgecombe was in fact inflating like, about 7 or like 14 centimeters a year at a measurable rate, which is just very fun. It didn't actually erupt, and has since kind of gone down to background levels of activity. But this is kind of like another spur-like example of how somebody's looking at an aspect of the volcano, and that aspect is drastically changing. So it gets a bunch of people worried, like, are other things going to start changing about it? And sometimes it doesn't. Sometimes we get these failed eruptions. It adds spice into it, it makes things a little difficult.
Well, I just want to be mindful of the time. It is 1 o'clock. So if you're able to keep answering questions, Skye, I appreciate
I
it.
am happy to answer questions. I owe everyone that much. Again, I'm so sorry.
Well, just to bring it back to Bristol Bay, are there volcanoes in Bristol Bay that you think deserve more attention or have some scrutiny on them right now?
I mean, Aniakchak, Ugashak these are all like Holocene volcanoes that are like close enough, but you're still like, just a scooch back into the arc, right? I think they're like a lot of the actual interest, like in potential threatening eruptions, these are all happening on like the front end of the Alaska Peninsula. So once you start to get further back, like there are still Holocene volcanoes back there. Yeah, Togiak, for example, which I mean is listed on the Alaska Volcano Observatory website. It's just, there's so many of these things and we don't understand them in this state. There's this huge amount of geological things, geological events, geological terrains, bits and pieces of how the state has like come together and evolved over the last, many hundreds of millions of years that we just still don't fundamentally understand large segments of it just because we have a lot of land and we only have so many geologists, right? It's kind of what makes geology so cool is like we haven't done enough of the research around here to really understand how, these little bits and intricate pieces of the state have come together. What have past Togiak eruptions looked like? How long ago were they? Were there several? How impactful were they in different parts of the state? We have, in some areas, large ash beds, things that have been, produced from volcanic eruptions that we don't necessarily have correlated to a specific volcano. We don't know what produced it. And I think historically we get some like very large eruptions. There's a paper that a couple of people put out to go a couple of years ago suggesting that, Okmok volcano, which had like a very large voluminous eruption in the early, like 49 BC or something, kind of led to like the decline of the Roman Empire because you have this huge amount of ash that gets put into the atmosphere. It causes global cooling for a couple of years, and that then relates to famine and a bunch of stuff. And I think that there have been like, a lot of historic events in the state that aren't necessarily correlated to like they have had large external environmental factors, and we haven't like fingerprinted everything yet. Which is to say, no, nothing around Bristol Bay that I'd be super, super worried about, Trident.
I'm glad
Thank
to
you.
hear that. So is scooch an actual word? And is there like,
A scooch?
is that like, sorry, I always like my brain couldn't get off a scooch where when you said
So
that.
sorry. No, non-jargony word. Just a little bit.
Just
Any
had to
other-
ask.
Any other questions?
Yeah, I'll ask a couple questions. So you may have already addressed this, but how many monitored versus unmonitored volcanoes would there be in Alaska? Just give a quick explanation of that. And then also, if there was an unmonitored volcano, are there any circumstances or criteria that would encourage it to become monitored if there was a lot of activity going on, or is it
Yeah.
just
Huge problem in like it's a very difficult thing to deal with. So like because the definition of like monitored versus unmonitored in this state is like baked into having three working seismometers around it within 20 kilometers, we can often, especially in the winter, like lose power to a station. Around Spur, for example, a lot of the stations that have historically, they've like buffered things a bunch now. They've gotten a scooch better. But like, if a station goes offline in the winter, that volcano suddenly switches to unmonitored, right? Because now you're down to two. So like sometimes if activity will bump up at a volcano, then like people can do things to restore telemetry. In the case of Spur, at least it's close to Anchorage, so like people will get into a helicopter and they'll dig a station out. Often people were doing that for like the last uptick in activity, and it just becomes really onerous. There's no like high threat volcanoes or things that are regularly active as of now that are like really drastically unmonitored. Uh, there is a good example of Cleveland volcano. It's out in the island of Four Mountains. It's like two chains down from Dutch Harbor. Uh, yeah, I guess Dutch Harbor, then Okmok, Nikolsky, and then Cleveland. There's nobody there currently. But that volcano and that area is kind of, again, hard to work around, remote, but also everything in the state is kind of in a state park. So it's very difficult to also set up systems inside of it. The permission structure is not easy. Uh, but yeah, Cleveland didn't necessarily have a complete network around it for, until 2021, 2022. But has historically had eruptions pretty regularly every year. So that's an example of like something that does erupt and like was never listed as like monitored. Uh, Whether or not a volcano is monitored though, like you can still be like, this volcano is erupting. We're putting it at yellow.
right? Yeah.
I have a question.
Amazing.
So my name's Patty. I apologize. I was late coming here.
I apologize. I too was late,
Perfect. So I guess, and Cav had asked about volcanoes in our area that could affect us. I think some of the reasons that I came today was not so much volcanoes in our area that can affect Bristol Bay, but the side effects of other neighboring volcanoes, like ash fallout. When
Yeah.
the Russian earthquake volcano occurred, and then it was kind of a big mess. One of the things that I struggled with was to find the ash fallout. So I'm really happy to see that the AVO maybe I didn't see it before, but now it looks like it's a lot easier to follow with this new tools and website.
Yeah, the tools have been like have gotten better for it.
So then I think I think one of the struggles that I had, I work at the tribe, and one of the things that I work on, and this reflects back to what Sue was saying about IGAP and community preparedness, that kinds of thing, is that I really struggled to find how that event was going to affect, if anything, our region. And it didn't so much affect us here locally, but it did affect higher up, and still continues to do so with like the Bethel and above area.
Yeah. I mean, sorry.
That's what I'm looking for is what kind of things can our area expect from not so much local volcanoes, but the side effects of other neighboring volcanoes.
Yeah, I mean, that's, I think, the big question that everyone's asking at like administrative levels in this state. Like, how do we have a better understanding of where ash is going to go? It's like there are a couple of tools that if you give me your email, I'd be happy to direct you to beyond, you know, like just the AVO website.
Yeah,
But
I can put you guys in touch.
yeah, but it's like it's genuinely such a difficult task to like understand where ash is and then like where it's going, the atmosphere. I can So one example of like a pretty helpful tool, there we go. It's like usually all the ash stuff, very helpfully, real easy to see via satellite. Uh, Satellites are good at detecting and understanding, you know, is there ash? Is there volcanic ash or dust in the atmosphere? This, for example, is a scan from a satellite, TROPME. It's measuring essentially like the quantity of ash that's around in the atmosphere. These huge dust clouds setting around over the Sahara kind of happen annually and usually like blow out towards South America. When we have large volcanic eruptions, we can usually track ash, or at least we can see it as volcanoes are moving in the state, but like the actual prediction of how much ash there is, where that ash is going, and how long it will be in the atmosphere is very hard to understand. And then beyond that, whether or not planes can fly in it then becomes an interesting question. So like we don't necessarily know as like a pure matter of science how much ash a plane can actually fly inside of. We know it's very bad for plane engines, but like,
That we do know. I used to have a plane and we knew not to fly one, but this is really kind of more, in a sense, question for you and also Tab, anybody else. We're talking about ash, acidity. How does that impact salmon returns and just, the health and so forth? Because I'm assuming that there's been some correlation, some studies and so forth. And then because I have to leave, if I ever meet you in person, Skye, I'm going to call you either Scooch or Hooch. Sorry, I can't resist.
You're good. No, I have genuinely not looked into the causal link between ash and fish health. I know that other people do.
Because that just seems like, again, I really appreciate Alaska Sea Grant putting on these, sessions and so forth. And, because fish is everything to us here in Bristol Bay.
Yeah.
And that's why I think people are also interested in your presentation and others that, are forthcoming.
Yeah, one of the things that I guess so it's hard to find people who are like quantitatively looking at, every aspect of like volcano to like fish interaction. A lot of what I do, for example, a lot of like what I'm interested in research wise is looking at mercury emissions from volcanoes. So there are some people that feel that they're like volcanic environments that do have like, they've gone and looked at like seals and other fish near volcanoes and have measured anomalously high concentrations of mercury in like those fish. But then like there are other volcanoes in the state that are active and we don't necessarily see this pattern.
Thank you.
Dynamic environments.
Well, thank you, Skye. Appreciate it. Thank you, guys.
No worries. I appreciate you again. Talk soon.